Hello, myself Alok Kumar and I am from Group 182A 1. My topic is mechanism of muscle contraction. So let's start the video. First we will see the structure of the skeletal muscle. So it is composed of the muscle fascicles, muscle fibers and the myofibrils, and you can see the picture of it also. Now the skeletal muscle, it has muscle fibers in which the muscle fiber have the sarcolemma, sarcoplasm, the myofibrils which is the contractile element, and it consists of the actin and myosin. Now the actin filament, and actin filament has F-actin strands, tropomyosin, troponin, and troponin has T, I and C troponin. And now the myosin filament. Now the structure of the myofibril, as you can see in the picture, there the sarcomer, the tropomyosin, and how the G actin molecule look like, and the troponin, and the myosin, how it is look the coiled portion of the two alpha helicals and the two heavy chains. And we can also see the actin myofilament which is thin and coiled in shape, and the myosin myofilament which is thick. Now the mechanism of the muscle contraction. So in step 1, what will happen? The nerve impulse travels toward the synaptic node, and in step 2, the calcium ion from ECF enters into the synaptic node through calcium channels. Then in step 3, as calcium enters into synaptic node, the acetylcholine vesicles ruptures and acetylcholine release out into synaptic cleft by exocytosis. In step 4, acetylcholine diffuses across the neuromuscular junction and binds to the receptor site on the postsynaptic membrane. In step 1 to 4, this picture describes all the stages, how calcium ions binds to the neurotransmitters, and then in the postsynaptic, presynaptic junction, as you can see how the neurotransmitters are merged and goes into the synaptic cleft and going to the postsynaptic membrane to do the transmission. And it has several parts: neurotransmitters, the receptor, the postsynaptic membrane, ion channel opens there also, and all that. Now in step 5, stimulating of the receptor causes the conformational change in postsynaptic membrane and generate an action potential, and the acetylcholine is destroyed by an enzyme acetylcholinesterase. Now in step 6, this action potential travels along the length of the muscle fiber and then penetrates deep into the muscle through T-tubular system. In step 7, as we can see here, the electrical impulse stimulates the sarcoplasmic reticulum to release the calcium into the contractile unit of a myofibril area. Now in step 8, the calcium which bind with the troponin C and activates myosin ATPase. As myosin ATPase become active, tropomyosin slipped off and the G action exposed. ATPase react with the ATP. So as we can see, when ATP react with ATPase in the presence of calcium ion, it converted into the ADP and phosphate, and some energy will release and more muscle contraction takes place. Now the muscle contraction which occur when calcium is pumped back into the sarcoplasmic reticulum away from the actin and myosin, and when calcium moves in this way, the actin and myosin cannot interact and muscle relaxes. Now you can see in this image the sliding filament where the Z line, A line, the Z area we can see here, and actin and myosin also you can see. Then in contraction, what will happen? The I band disappear, H band disappear, M band disappear, and the length of sarcomer disappear. Now in sarcomer relaxed. We can also see the sarcomer partially contracted in this image, and this is the stage where the sarcomer completely contracted. Thank you. Have a nice day.